I wanted to start, I wanted to begin the last video for the review session with a problem that maybe some of you may find very easy, but we have seen that students may struggle with this kind of question in the past. And this has to do with recognizing the kind of the points points where a function fails to be continuous, and we have to do this algebraically. It's not that you're given a graph. That's not the case. You're just given an expression for f, and you have to identify where that function is discontinuous. So let's start with the following exercise. We let f of x be equal to, say, 3x plus 1 divided by 4 minus the absolute value of 5x minus 1. So at which points is f discontinuous? So that's one way that we can ask you about this, about finding the points of discontinuity for a given function. Another ways we may give you some alternatives, so some choices, and we ask f the function f is discontinuous at, and you may be given a bunch of options, so it's a few options: A, B, C, etc. And this may consist of more than one option, so may actually be numbered at, well, we may actually give you 1, 2, 3, and then you have to select. I mean, there's 1, 2, only one, none of the above, or all of them. I mean, whatever. There are many combinations. But this is the kind of problem, and the only idea here is to get a sense of whether you understand algebraically what it means. I mean, how this kind of functions can fail to be continuous. Remember, but we're just going to solve the most general question. We're going to find all the points which this function f is discontinuous. And so what we want you to remember, to keep in mind, is that when you have a function like this, so remember the f of x is just some, we have a polynomial here. It's a polynomial of degree 1, so it's a very nice function. And here we have 4 minus the absolute value 5x minus 1. This function here is continuous, it's a polynomial. In the bottom, this function, well, a constant is continuous. The function absolute value, and absolute value for a continuous function is a continuous function as well. So this whole thing in the bottom is continuous. So how can this expression fail to be continuous? And that's what we're really trying to test here. Whether you understand that this kind of function, so you have a quotient, some function is defined as a quotient of two functions. If the numerator and the denominator are both continuous functions, how can this function fail to be continuous? And where will that happen? The only way that this could be discontinuous is if this function is not defined. And what can make this function undefined? Certainly not the numerator. The only problem is when you're dividing by 0. So no matter what happens with the numerator, if the denominator becomes 0, then the function will have discontinuity because the f will not be defined there. So the function is discontinuous where the denominator is equal to 0. And so that's the only point we're trying to make here, that when you have expressions that are defined as a quotient of two functions and both functions are continuous, to look for discontinuities, this means to look for zeros of the denominator. Okay, so the denominator becomes 0, so 4, well, the denominator here is 4 minus the absolute value of 5x minus 1. And when will this happen? This happens when the absolute value of 5x minus 1 is equal to 4. And there are two options here. So either what's inside is 4 or minus 4. The absolute value of minus 4 is 4. And, well, the absolute value of 4 is 4 again. So those are the only two possibilities for what's inside the absolute value. So let's look at the first one. So first option is 5x minus 1 being equal to 4. Which then implies that 5x is equal to 5, which implies that x is equal to 1. The second option, the second possibility, is that 5x minus 1 is equal to minus 4, which will imply, if we add 1 on both sides, that 5x is equal to minus 3, which will then imply that x is equal to minus 3 over 5. Okay, minus 3 over 5. So these are the two options. Remember, keep in mind what we wanted to accomplish. We wanted to find the zeros of the denominator here, because, I mean, we're given a quotient where both functions, I mean, the one in the top and the one in the bottom, are both continuous. The only way an expression like this can be discontinuous is when the denominator is equal to 0. So we're trying to find the zeros of the denominator. And this will happen again when, this is the conclusion, when the absolute value of 5x minus 1 is equal to 4 in this case. And we further analyze how this can happen. And we have two possibilities for what's inside the absolute value. So that what's inside is equal to 4 or minus 4. And these two options lead to two possible values of x. The first one is x equals 1, and the second one is x equals minus 3 over 5. So we found the zeros. So these are the zeros of the denominator. So these are the zeros of the denominator. And so for these values, 5x minus 1 is equal to 4, which implies that f is discontinuous at these points. Okay, so the only 2 points where f is discontinuous is where x is equal to 1 and x equals minus 3 over 5. And that's it. So again, once you're asked to find the points of discontinuity of a function where both the numerator and denominator are continuous functions, you're just asked to find the zeros of the denominator. Okay, so that's the most basic thing here. The very basic thing that we want to test is whether you understand that the only discontinuities come from points where the denominator is equal to 0. And then to find, and if you are able to find those zeros, which is just some algebra. Alright, so then our next kind of exercise that I wanted to go over with you once more is something that some of you struggled with in the last quiz. Something that I actually stressed that week, and I gave you a selection of problems for last week, where you were asked to do the same thing. But since some of you didn't get it right, I thought it would be worthwhile looking into it again to one more example. This concerns the kind of question where we ask you to find the derivative using the definition. So let's suppose that we ask you to find, so that let f of x be equal to some quadratic. I mean, just the most simple thing in the world, x squared minus 7x, say. Find f prime of x using the definition. And here, when we say using the definition, we mean the limit, computing the actual limit that allows you to find the derivative, not the rules of differentiation that concern that have to tell you immediately what the derivatives are for power functions. So the power rule cannot be applied, and other rules cannot be applied either. I mean, we're explicitly asking you to find f prime using the definition. You already had a quiz that asked you to do that. I told you many times in the lectures last week. I mean, I told you last week multiple times. I warned you about this. We have the problem set from last week, and we solved 3 problems, I think, and they're all very much like this problem, and they're almost identical. I mean, one of them is almost identical to this one, and it's very similar to what you'll see in the exam. So if someone computes the derivative completely ignoring what I've just said, I mean, I won't have much choice but to, I mean, I won't be able to be giving them partial credit. So please pay attention to when we say that you have to use a definition. This is something that I insisted on, and I hope that you take me seriously this time. Okay, there's going to be a problem like this. It's going to be very, very similar, and so you just need to understand this example well. Okay, so there's no excuse for not getting this problem right in the exam. Okay, so the solution here f prime of x. So we're using the definition. Remember that we are asked to find the derivative by definition. So that means that we're asked to find the limit when h approaches 0 of f of x plus h minus f of x, all of that divided by h. Okay, so we need to see what f of x plus h is. F of x plus h is, so what do we do to what's inside of f in the argument of f? First we raise it to the square. In this case, what's inside f in the argument of f? X plus h. So we raise it to the square, and then we subtract minus 7, that quantity that we put inside f in the argument of f. So minus 7 x plus h. This is what the rule tells you to do. So take what's inside, raise it to the square, and then subtract 7 times that. Okay, so that's what it is. In the same way, when we're evaluating at x, we just get, well, that quantity squared, which is x squared, minus 7 times x. That's just the definition of the function. So that's what we do to every single number. So now we need to subtract these two expressions and divide by h and take the limit when h goes to 0. We can further expand this expression here. So x squared, x plus h squared is x squared plus h squared plus 2 times x times h. Times x times h. So that's just the first term. And something that happened to many of you, minus 7 times x plus h, when we open the parentheses, when we distribute, we change the signs of what's inside. So 7 and minus 7x minus 7 times h. When you distribute here, you bring the sign, you flip the signs here because you are multiplying by minus 1. Okay, so now we're gonna put this expression here because that's f of x plus h. So x squared x squared plus h squared plus 2xh minus 7x minus 7 times h, and then minus again. Be very careful. We're subtracting f of x. F of x is x squared minus 7x. And we divide all of that by h. This is the limit when h goes to 0 of x squared plus h squared plus 2x times h minus 7x minus 7h minus, and then be very careful now. We are bringing a minus inside. We're distributing a minus 1. So since x squared is positive, has a positive sign, a plus 1 in front of it, multiplying that. So you can think of x squared as being plus 1 times x squared. Then that is turned into minus x squared. Now when you distribute this minus inside, for the second term you have minus minus, so that becomes a plus 7x. We divide all of this by h. We get the cancellations we were supposed to get, so x squared and x squared, 7x and 7x go away, and then we are left with computing the limit as h approaches 0 of h squared plus 2xh minus 7h divided by h, which is equal to the limit when h approaches 0 of h times h, when you bring this inside, becomes h squared, which is the first term that we have here. Then to get the second term, namely this one, we add 2x. So when we distribute, that becomes 2xh, and then we need to get the third term. That's just 7, minus 7. So minus 7 times h is minus 7h. And we divide that by h. That's the same thing here. So, I mean, we have to keep dividing by h every time. But now, remember, h is not 0. We already know that. And so we're just taking the limit when h goes to 0 of the h plus 2x minus 7. 2x minus 7 actually remains the same because we're not, those two quantities don't depend on h, but h goes to 0. So we just left with 0. 0 plus 2x minus 7, which is in the end just 2x minus 7. And that's the final answer. So that's the derivative of this function, and this is how you obtain it by definition. First thing to do, of course, is to just write down that f prime has to correspond to the limit of f of x plus h minus f of x divided by h as h approaches 0. The second thing to do is to write down explicitly what f of x plus h is. Okay, and that just means writing in the formula for f, wherever it says x, just replace it by x plus h. So here and here. And then you subtract those two things. I mean, f of x plus h and f of x. Be very careful with the sign. If you're distributing things with parentheses, I mean, multiplication minus 1. If you're distributing that, then be very careful to get the right sign. And then after all the cancellations and all those simplifications like in here, because since we are we are not really allowing h to be 0, we can cancel h's out. And we can simply evaluate this when h is equal to 0 to obtain that this is just equal to 2x minus 7. Okay, so that's the procedure, and this is what you have to do every time, and this is what you'll have to do during the exam. Okay, one last thing that I wanted to go over with you is it's a problem involving finding the equation of the tangent line. And in fact, here this is not something that you really that you've not done right. It's just that for this particular kind of problems, we're not asking you to use now to find derivative by definition. So only in problems where we specifically ask you to use the definition, so in those kinds of problems, you're expected to use the definition. For all the other problems, just use the known rules. Okay, so here in particular, don't try. I mean, some people attempted to find the derivative of a certain function by, in the last quiz, by definition. You don't need to do that anymore. Only in the problems where we're asking you to find the derivative of a given function by definition. The reason why we found the derivative of a function by definition when solving a problem about finding the equation of the tangent line was because at that point we hadn't given you the power rule or the rules of differentiation at all. So we had to compute everything from scratch. Now that we've done that, you don't need to do it anymore. So save some time during the exam and you can use the rules here. The only place where you cannot use them is, again, when you're asked specifically about, And specifically, you're told to use a definition to find the derivative. And so you cannot avoid using the definition. For all the other problems, you can simply go ahead and differentiate things in the way you know how to, using the power rule and the derivative of the product rule, the quotient rule, and all that. Okay? So in particular, when you are asked to find the tangent equation of the tangent line, you don't need to compute the derivative by definition. You can simply use the rules. Okay, so this should be a problem that you should be able to get almost immediately. So this kind of problem should be one of the easier ones. So you have to find the equation of the tangent line for a given function, x cubed times e to the x in this case, when x is equal to -2. For the solution, again, we notice from here that RA is -2. Okay, so what is f of a? F of a is f of -2, which is -2 cubed times e to the -2. -2 cubed is -2 times -2 times -2, which is -8 e to the -2. Okay, so we have a, we have f of a, which is this, and we just need to find f prime of a. So now, what is f prime? What is f prime of f? It's x cubed e to the x prime. And here we use this is a product of two functions. So we can use the product rule. And the product rule is something that you just need to memorize. But it's just the derivative of the first function times the second one plus the first function times the derivative of the second function. Again, now we use the power rule. So now we need to use the power rule. For x cubed. And so alpha here is 3. So we get 3x, 3 to x to the 3 minus 1, which is just 2, times e to the x plus x cubed times, and what's the derivative of e to the x? Well, just e to the x itself. We have a common factor of e to the x, so we write this as this, so 3 e to the x on 3x squared plus x cubed. This last step is not really necessary. Here you're just interested in what is the value of f prime at -2. So we simply need to evaluate this expression at -2. This is the derivative of f for any x. So we need to evaluate it at -2. So we have e to the -2 times 3x squared plus x cubed. What is, well, this is just 4. And then plus x cubed, so -2 to the third. So this is just equal to e to the -2 times, again, here we have 12 minus 8. And this is equal to 4 times e to the -2. So that's f prime at -2, which is f prime at a. So what is the equation of the tangent line then? It's y minus f of a, and we just computed that f of a is equal to minus a times e times e to the -2, and this is equal to f prime at -2, which is 4 times e to the -2 times x minus a. And what is a is -2, so we have to write -2. So this just becomes y plus x e to the -2 is equal to 4 times e to the -2 times x plus 2. And this is our answer. So this is the equation of the tangent line for f, of the function f of the point x equals -2. So this is the last thing for the exam. I mean, I hope that you go over the lectures and all the problem sessions and all the problem sets and all the suggested problems, and follow my advice, and pay special attention to the problems that I've tried to draw your attention to. And well, I wish you luck for the exam, and that would be it. Yeah. So we'll come back to the lectures next week. Then that's it.